Ever get that feeling where you're seeing some incredible new technology, like the latest AI stuff, but how it actually works behind the scenes feels like, I don't know, magic?
Oh, definitely. Like you see the amazing result, but the connections, how all the pieces talk to each other, it can feel pretty opaque.
Yeah, exactly. Especially with this stuff people are calling agentic AI now.
Right. That term is popping up everywhere. And it's a good distinction to make, actually.
Okay, so agentic AI, let's unpack that. How's it different from the AI we maybe already know?
Well, think of it like this. A lot of AI we use today is more like a tool, right? You give it a command, it responds.
Okay.
Agentic AI systems are, well, they're designed to be more autonomous. They have goals, they can sense their environment, reason about it, make decisions, and act on their own.
So more independent.
Exactly. And the really interesting part, they often work together. You have multiple AI agents, maybe specialized ones, collaborating on complex problems. Problems too big for just one AI.
So less like one giant super brain.
Yeah, much less.
And more like a team of AI specialists coordinating.
Precisely. Like a team of experts, each bringing their own skills to the table.
Okay, that sounds powerful, but also way more complex to manage.
Absolutely.
Yeah.
That's the trade-off. But the potential upside for businesses is huge.
How so? What kind of value are we talking about?
Think about automating really intricate processes,
Mm-hmm.
things that need lots of human back and forth right now,
Mm-hmm.
or augmenting human teams, letting AI handle the repetitive data stuff so people can focus on higher level work,
Right.
or even better decision making because these agents can pool their insights. Imagine customer support AI agents, triaging requests, maybe solving simple issues, routing the tough ones perfectly.
Okay, I can see that, like a smarter front line.
Or think about supply chains.
Mhm.
Multiple agents constantly monitoring, adjusting for disruptions in real time. That kind of dynamic optimization.
Wow, okay. The potential is definitely there. But going from one smart AI app to like this whole web of them working together across a big company,
Yeah,
that feels like a monumental leap, a really big step.
it is. It's a significant undertaking, no doubt about it. And that's precisely what we're diving into today.
Ah,
Our mission, if you will, is to unpack the essential things you need to actually scale this agentic AI stuff
yeah.
in a real enterprise setting.
Gotcha. And we're basing this on,
We're drawing heavily from insights in a recent white paper called Scaling Agentic AI in the Enterprise.
okay. So for you, the listener, think of this as your shortcut. We've dug into this detailed paper and we're pulling out the key platform pieces, the best practices you need to understand how to go from maybe one or two agents to really deploying them widely and getting value. Your insider's guide, basically.
Exactly. How to build the foundation for this stuff to actually work at scale.
Right. So the first thing that jumps out at me is coordination. How do you manage potentially hundreds, maybe thousands of these things working together?
That's the million-dollar question, isn't it? It's not enough for them to be smart individually. They have to coordinate.
Yeah, you can't just let them loose and hope for the best.
Definitely not. Which brings us neatly to our first big topic, multi-agent orchestration.
Okay, orchestration. Makes sense. How do you direct this AI team?
It's all about how they coordinate their actions, how they communicate, divide up tasks, find each other when they need a specific skill, and manage these complex workflows.
And the white paper suggests different ways to do this.
It outlines two main approaches. The first is called orchestration, which is more centralized.
Centralize, like a boss.
Kind of. Think of a conductor leading an orchestra. You have one central agent, or maybe a dedicated service, acting as the conductor.
Okay.
It controls the flow, assigns tasks to other musician agents, gathers the results, manages the sequence.
And the benefit there is?
Control. Clarity. You have a clear overview of the whole process. Easier to monitor, easier to fix if something goes wrong, easier to recover.
Makes sense. Can you give a concrete example?
Sure, the paper uses loan application processing.
Right.
A central orchestrator gets the application. It then tells agent A, do the credit check, then tells agent B, run fraud analysis, then agent C, verify income docs. It manages that whole sequence.
Step-by-step instructions.
Pretty much. It uses command-driven communication. Do this, telling when you're done. Good for structured, predictable processes.
Got it. Central control for clear workflows. What's the alternative?
The other main approach is choreography. This one's decentralized.
Decentralized. Okay, how does that work?
Think less orchestra, more
Mm-hmm.
ballet. The agents react to events happening around them.
Events.
Yeah. Instead of getting direct commands, agents publish events to a shared message bus or stream, like shouting out, hey, I just finished this.
Oh.
Other agents subscribe to events they care about. When they hear a relevant event, they react and do their thing.
So they're listening for cues, not waiting for orders.
Exactly. Communication is often asynchronous. The agent publishing the event doesn't wait for a reply, might not even know who picks it up. It's loosely coupled.
Interesting. What's an example here?
The paper suggests an agent publishes a new loan application received event.
Okay.
A credit check agent, subscribed to that, sees it and starts its work. When it's done, it publishes a credit check completed event.
Ah, triggering the next step, potentially.
Right. Maybe a fraud analysis agent picks that event up and starts its process.
That sounds more flexible, maybe more resilient if one agent hiccups.
It definitely can be. Better scalability, more resilience. If one dancer stumbles, the rest of the ballet can often continue.
But how do you track the whole thing? Seems like it could get confusing without a conductor.
That's the trade-off. It can be harder to understand the overall flow, harder to debug, because there's no single place holding the whole process state. It emerges from the interactions.
So different styles for different needs? Is it always one or the other?
Not necessarily. The white paper actually recommends a hybrid approach quite often.
Hybrid? How so?
Use orchestration for the main high-level business flow where you need that control and visibility. But within certain steps of that flow, you might use choreography for more flexibility among a subgroup of helper agents.
Ah, okay. Like the conductor leads the symphony, but the string section has its own internal cues.
Exactly like that. Best of both worlds, potentially.
Now, if you have all these agents, maybe built by different teams or even different companies, how do they speak the same language? Do we need, like, an AI universal translator?
That is a huge challenge, and it's where standardized communication protocols become absolutely critical for interoperability.
Standards, okay. Are there any emerging?
Yes, the white paper specifically highlights two important ones that are gaining traction. Anthropic's Model Context Protocol, or MCP,
MCP?
and Google's Agent-to-Agent Protocol, or A2A.
Okay, MCP and A2A. Let's take MCP first. What's the main idea there?
Think of MCP as trying to standardize how agents give and get context when they talk to each other, or when they use tools or APIs.
Context, like background info.
It's exactly sharing relevant data, user profiles, documents, the current state of a task, and also standardizing how an agent requests an action from a tool or another agent.
Okay.
The paper uses a great analogy. It's like trying to create a USB-C port for AI applications.
Huh. I like that. A universal connector.
Right. A standard way to plug things together. It defines input-output structures, how context gets passed. So Agent A knows how to give Agent B the info it needs and how to ask it to do something in a common format.
Regardless of who built Agent A or Agent B.
That's the goal. Model-agnostic, context-driven communication. It can massively cut down on custom integration headaches.
Yeah, I could see how that would help. So MCP is about context and interacting with tools or other agents. What about Google's A2A? Is it similar?
It's related, but has a slightly different focus. While MCP is maybe broader agent-to-anything communication with a focus on context,
Okay.
A2A is specifically designed for agent-to-agent collaboration, getting agents to talk directly to each other seamlessly, even across different platforms or vendors.
So A2A is really focused on the dialogue between the AI agents themselves, task delegation, that sort of thing.
That's a good way to put it. A2A defines how a client agent can find and get help from a remote agent. It has a few key parts.
What?
First is agent discovery. How does an agent find another one that can do what it needs?
Good question.
A2A proposes using an agent card. It's basically metadata, often in JSON format, describing what the agent can do, its capabilities.
Like a little business card for the AI.
Exactly. Hi, I'm the translation agent. I translate English to French. Or I'm the CRM agent. I can access customer data.
Okay. And how do agents find these cards?
Could be a central registry, like an app store for agent skills, or maybe shared peer-to-peer. The client agent searches this registry or network for an agent with the capability it needs.
That's clever, like an internal search engine for AI skills. What else is an A2A?
Task messaging. It formalizes the idea of a task. The client sends a task object to the remote agent.
A specific format for requests.
Yes. And this task object has a defined life cycle. In progress, completed, failed. The remote agent can even send updates for long tasks.
Ah, so you can track progress.
Right. And when the task is done, the remote agent sends back an artifact, That's the result data, a document, an image, whatever the task produced.
Structured results too. Nice.
Very structured.
Yeah.
And it also handles structured interaction. Messages can have multiple parts, text, an image, maybe a suggested action, each labeled with its content type.
So you can send complex messages.
Yes.
Okay.
And there's even a negotiation mechanism if agents support different formats. Like, can you handle a chart? No, just give me text. They can sort that out.
Wow, okay. That's quite thought through. What about security? That seems critical.
Definitely. Security and governance are built-in considerations. Authentication, proving who you are, and permission checks, are you allowed to do this? These can be part of the protocol or pluggable, so
Yeah.
companies can use their existing security setups. Agent cards can list required permissions. Messages can be signed. It's designed with enterprise needs in mind.
That's reassuring. So these protocols, MCP and A2A, they seem really foundational for making this multi-agent thing work smoothly. The paper had a customer support example for A2A, right?
It did. Imagine a support agent, maybe an AI itself, handling a complex refund.
Okay.
Using A2A, it first discovers a policy agent that knows all the company refund rules. It sends an A2A task. Here's the situation. Is this customer eligible?
Right.
The policy agent replies with an artifact. Yes, based on Rule X, here's the eligible amount.
Got it.
Then the support agent needs to actually process the refund. It uses A2A discovery again, finds the finance agent with permission to move money, sends another A2A task, process this refund for this amount to this customer. The finance agent does it, sends back a confirmation artifact.
And the original support agent didn't need to know the nitty-gritty details of the policy or finance system?
Exactly. It just used the standard A2A protocol to find the right agent and delegate the task, breaks down silos, enables seamless collaboration.
That really paints a picture, shows the power. The paper does say these are still evolving standards, though.
Yeah, they're relatively new. MCP and A2A are still developing. But adopting these kinds of open protocols early, that seems key for building a flexible, future-proof agent ecosystem in an enterprise.
Avoids locking yourself into one vendor's way of doing things.
Precisely. Fosters interoperability and innovation.
Okay, so we have ways for agents to talk and understand each other. But what about the underlying plumbing? The infrastructure needed to support all this collaboration. The white paper mentioned a core orchestration layer.
Right. Think of that as the essential middleware, the foundational infrastructure that makes large-scale multi-agent cooperation possible and manageable.
The engine room, sort of.
Kind of. And the paper breaks it down into several key components.
Okay, lay them out for us. What are the non-negotiables for this layer?
First up, a service registry and discovery mechanism.
The agent phone book we touched on.
Exactly. A central place where agents register themselves and advertise their capabilities, maybe via those A2A agent cards or similar metadata.
So other agents or an orchestrator can find who does what.
Precisely. Who can translate French? Who has access to the product database? The registry answers that. It needs to be dynamic, always up to date, scalable, and highly available.
Makes sense. How do people build these?
Could be a dedicated database, could leverage things like Kubernetes services with labels, or tools like Console. The key is keeping it current and performant.
Okay, registry and discovery. What's next?
If you're using that centralized orchestration approach we talked about,
The conductor model.
right, then you absolutely need a workflow engine orchestrator. This is the component that actually runs the predefined process flow.
It executes the steps.
Exactly. It calls agent A, waits, gets the result, calls agent B, handles branching logic. Credit scores low, do this. Manages retries if something fails. Maybe handles compensating actions if a step errors out midway.
So it's the brain managing the sequence.
Correct. The paper uses an onboard a new employee example. The workflow engine calls the HR agent, then the IT setup agent, then the training agent, in order. It maintains the state of the whole process from start to finish.
Are there specific tools for this?
Oh yeah, you could build custom or use established tools like Communda, Temporal, or cloud services like AWS Step Functions or Google Cloud Workflows. Lots of options.
Got it. Workflow engine for centralized control. What if you're doing the choreography thing? The ballet?
Then you need an event bus message broker. This is the communication backbone for event-driven systems.
Where agents publish and subscribe to those events.
Precisely. Agents publish messages, employee created, order shipped, inventory load to the bus. Other interested agents subscribe and react asynchronously.
So the sender doesn't need to know who's listening.
Right. It promotes that loose coupling. Common tools here are Apache Kafka, RabbitMQ, or cloud services like AWS EventBridge or Google PubSub. They need to be high throughput and reliable.
Okay, event bus for decentralized comms. What else is essential in this core layer?
Security is paramount. So you'll need an agent directory and authentication service.
To manage who's who and who can do what.
Exactly. Manages agent identities, verifies them using things like OAuth tokens or certificates, enforces permissions this marketing agent cannot call the finance agent's process payment function.
Right, critical controls.
It integrates with the service registry and maps identities to roles and permissions. Think security checkpoint and authorization manager for all your agents.
Makes total sense. What's the last piece the paper highlights?
For complex, maybe long-running workflows, you might need a state management memory store.
A place to keep track of progress.
Yeah, essentially a shared place, maybe a database, maybe something fast like Redis, where agents can store intermediate results or shared context needed for the overall process.
When would you need that?
If the workflow is very intricate, or if agents themselves are stateless and need a central place to coordinate state, or if an agent might stop and restart later. Though, as we said with A2A, sometimes state can just be passed in messages. But for complex cases, a dedicated store helps.
A shared scratch pad for the agents.
Yeah.
The paper mentioned cloud-native tech is often used for this layer.
Makes a lot of sense, right?
Mm.
Scalability, resilience, managed services. Kubernetes is great for deploying and managing the agents themselves, plus its service discovery helps.
Right.
Cloud event buses like EventBridge or PubSub are built for scale. Managed workflow engines like step functions simplify orchestration. Cloud native just fits well.
And what about frameworks like LangChain's LangGraph? Where do they fit in?
Good question. They sit sort of on top of this core layer. They provide higher-level abstractions for designing these multi-agent workflows, especially ones using LLMs.
So they make it easier to build the collaborations.
Yeah. You define agents as nodes in a graph, specify how data flows between them. It simplifies managing the interactions without needing to code all the low-level message passing or state handling yourself. They assume the core infrastructure layer exists.
So core layer is the plumbing. LangGraph is like a toolkit for building things with that plumbing.
That's a decent analogy. Core layer provides the foundation. Frameworks provide developer tools on top.
Okay, picture's getting clearer. Infrastructure is key. But just having the parts isn't enough. How do you make sure these workflows are actually reliable in the real world? Uptime, data consistency, that's crucial for enterprise stuff.
Absolutely critical. And that's where the next set of best practices from the white paper comes in, focusing specifically on building reliable multi-agent workflows. Managing this complexity reliably is a huge challenge.
I bet. What are the key principles here?
A foundational one is using modular agent contracts.
Contracts, like legal documents.
Not quite. More like clear API specifications for each agent. Define exactly what inputs it takes, what outputs it produces, any side effects it has.
Okay.
Formalize these using schemas, JSON schema, protocol buffers, like a strict API contract in microservices.
So everyone knows exactly how to interact with an agent.
Precisely. It defines the boundaries.
Yeah.
Take a translation agent, its contract says, input text plus source language plus target language, output translated text. Anyone using it knows what to expect. They don't need to know how it translates. This enables teams to build and update agents independently as long as they stick to the contract.
Clear interfaces. Makes sense for managing complexity. What else?
Loose coupling via events or APIs. Avoid agents directly calling each other's internal code.
Interact through the formal contracts or events we just talked about.
Exactly. Use those stable APIs or trigger actions via events in the message bus. This means you can swap out an agent implementation or update it without breaking everything else that talks to it. Kubernetes services, API gateways, messaging systems all help achieve this.
Keeps things flexible and less brittle. Good. What's next?
Schema versioning. Interfaces change. The data agents exchange evolves. You have to plan for this from day one.
Versioning the contracts.
Yes. Use semantic versioning, V1, V2. Include version info in messages. Try to make schemas backward or forward compatible where possible. Document changes rigorously. Validate schemas automatically.
So you don't break things when an agent updates its output format.
Exactly. If you make a breaking change, like adding a new required field, bump the major version. V1 may use V2. This signals downstream consumers need to adapt. Critical for stability.
Absolutely vital for long-term maintenance. Now, what about when things inevitably go wrong? Network blips, agent failures.
That's where implementing reliability patterns comes in. Standard stuff from distributed systems, but crucial here.
Like what?
Retry with backoff. If a call fails temporarily, try again. But wait a bit longer each time exponential backoff so you don't hammer a struggling service. And have a limit. Don't retry forever.
Smart retries. Got it.
Circuit breakers. If an agent keeps failing or timing out, stop calling it for a while. Trip the breaker, give it time to recover. Prevents one failing agent from cascading failure across the system.
Like an electrical breaker, stops the flow if there's a problem.
Exactly. Also, timeouts and deadlines. Always set a limit on how long you'll wait for a response from another agent. Don't wait indefinitely if something's stuck. Fail fast, move on, maybe try something else.
Prevents getting stuck. Makes sense. What about those asynchronous event messages?
Use dead letter queues, DLQ. If a message can't be processed successfully after retries, move it to a separate DLQ.
Why?
Prevents a poison message from blocking the main queue forever. Ops teams can then investigate the bad messages in the DLQ later without stopping the whole flow.
A safe place for problem messages. Okay. Anything else on reliability patterns?
Idempotency. Design agent actions, especially ones that change things, so doing them multiple times has the same effect as doing them once.
How do you do that?
Often using unique task IDs. The receiving agent checks. Have I already successfully processed task 123? If yes, just return the previous result, don't run the logic again. Crucial for systems with retries.
Prevents accidentally charging a credit card twice, for example.
Precisely. Super
Okay,
linked.
these patterns seem essential. What about the agent design itself?
Decoupling task logic from agents. Follow the single responsibility principle. Keep agents focused on one specific domain or function.
Don't build monolithic agents that do everything.
Right. Let the workflow engine or orchestration layer handle the overall multi-step process. Makes agents easier to understand, test, replace, and allows different teams to own different agents cleanly.
Modularity again. Good principle. What else?
Monitoring and adaptive routing. Continuously monitor agent health and performance. If you have multiple instances of an agent, route requests intelligently to the healthiest, fastest ones.
Like load balancing, but smarter.
Yeah, based on real-time metrics. Avoid sending traffic to struggling instances. Requires good observability, which we'll get to.
Okay. And the last best practice mentioned.
For data consistency, especially when you update a database and send an event.
Yeah, that seems tricky. What if one fails?
Oh, use patterns like the transactional outbox inbox. Write the event to a special table in the same database transaction as your main data update.
Ah, so they succeed or fail together.
Exactly. Then a separate process reliably reads from that outbox table and sends the event to the message bus. Guarantees consistency. An inbox pattern on the receiving end helps handle duplicates reliably too.
Ensures atomicity. Clever. These all sound like solid engineering practices, really, borrowed from microservices.
A lot of them are, yes. But they're even more critical with AI agents because the AI's reasoning can introduce non-determinism. Things might not behave exactly the same way every time. That makes robust orchestration and reliability patterns absolutely essential.
Right. The AI adds another layer of unpredictability. The paper mentioned tools here, too.
Yep. LangChain LangGraph for the high-level orchestration design. Hugging Face transformers for models. Kubernetes for deployment. AWS Event Bridge. Kafka for events. Temporal, Airflow, Camunda for workflow engines. A whole ecosystem exists.
Okay, so we've covered orchestrating agents and making the workflows reliable. But how do you manage these things once they're built and running? Deployment, updates, monitoring, the operational side.
Right. That brings us to a really crucial concept the white paper calls AgentOps.
AgentOps, like DevOps or MLOps, but for agents.
Exactly. It's applying those same principles, automation, monitoring, lifecycle management, specifically to autonomous agents. It's how you handle them from cradle to grave, ensuring quality, reliability, and governance.
Okay, so it's the whole life cycle. What are the key stages?
Starts with build, naturally. Defining the agent's goal, designing its logic prompts, algorithms, tool integrations, writing the code, using Git, documenting everything. Standard software stuff, but for agents.
Treat agent code like production code. Got it, then.
Test. And this needs to be thorough. Unit tests for the core logic, mocking dependencies, integration tests to see how it plays with others in a sandbox.
Standard testing. What about AI-specific testing?
Good point. Simulation and evaluation becomes important for complex agents. Simulate scenarios, use automated evals, maybe metrics like BLEU score for text or domain-specific checks, and canary testing gradually roll out a new version to a small slice of traffic first.
Test in isolation, test integrated, test behavior, test in production carefully. Comprehensive. After testing.
Deploy. Getting the tested agent into production. The paper strongly pushes for automated continuous deployment, CD pipelines.
Automation is key.
Absolutely. Consistency, repeatability, fast rollbacks. Containerize with Docker, deploy via Kubernetes or similar. Use infrastructure as code, Terraform Helm, to manage the environment. Tie deployments to specific versions. Use staging environments.
Standard CD best practices. Makes sense. What happens once it's live?
Then you're in the operate stage. Continuous monitoring performance, behavior, cost, incident response have playbooks, know how to roll back or disable a faulty agent quickly. Regular updates, new models, improved prompts, security patches,
Keeping it healthy and up to date.
and treating the entire agent definition code, prompts, model version, config as a single versioned artifact. Use an agent registry to track deployed versions.
Version everything together. Critical for tracking. What's the end of the line?
Retire. When an agent's no longer needed, have a process. Remove it from registries, let it finish current work, train tasks, archive its stuff, revoke its credentials. Clean shutdown.
Don't leave zombie agents around. Okay,
Yeah.
and governance fits in here too.
Yes, governance and approval spans the life cycle, but especially critical before deployment. Design reviews, automated policy checks, maybe manual sign-offs for risky changes baked into the CI/CD pipeline.
Oversight and control. So versioning seemed really important in that operate stage. Why emphasize that so much?
Because with agents, so many things can change the code, the prompt, the underlying LLM version, the configuration. If something goes wrong, you need to know precisely what combination was running. A single agent version ID that bundles all of that makes traceability and rollback feasible.
Got it. One version number for the whole package. The paper also dug deeper into testing strategies.
It did. Mention behavioral testing with scenarios. Give it input X. Does it produce output with property Y? Sometimes needs human evaluation, especially for language.
Testing the desired outcomes.
Adversarial testing. Actively try to break it. Edge cases, tricky inputs, maybe prompt injection attempts. See how robust it is.
Testing resilience.
Load testing. Can it handle the expected traffic volume? Consider underlying API rate limits too. Security testing. Check permissions. Input sanitization. Potential vulnerabilities.
A whole battery of tests necessary for critical systems. And the CI/CD pipeline for agents. How does that look?
Pretty similar to standard software CI/CD, but maybe with AI-specific steps. CI linting, static analysis, unit tests, maybe some basic behavioral tests, packaging the versioned artifact.
Build and initial tests.
CD deploy to staging, run integration tests, maybe automated canary deploy into production, monitor the canary closely, promote to full rollout, or trigger automated rollback if metrics look bad.
Automated, monitored rollout.
And tools like GitHub Actions, Jenkins, Argo CD are commonly used. The paper also mentioned feature flags.
For gradual rollouts without full redeployment.
Exactly. Turn on a new agent capability for just a small percentage of users first. Test in production safely. Maybe a new report generation feature for an agent. Flip the flag for 1% of users. Monitor, then gradually increase.
More control over releases.
Nice. And the governance part, how is that implemented practically?
Policy as code is big. Embed checks in the pipeline. Does the prompt contain PII? Does the output have banned words? Use tools like Open Policy Agent, OPA, for runtime checks too.
Automated policy enforcement.
Approval gates and CI/CD for manual review. Role-based access control, RBAC, for who can deploy what. Strict agent permissions principle of least privilege. What can the specific agent actually do? Securely manage its credentials, rotate them.
Limit the blast radius.
Detailed audit logging of agent actions. Who did what, when. Essential for compliance and debugging. And specific compliance checks. Does this meet GDPR? Does it follow financial regs? Might involve reviews, filtering, etc.
Building trust and ensuring responsible operation. AgentOps seems like a whole discipline in itself.
It really is. You can't just throw agents over the wall. You need this operational rigor to manage them responsibly and reliably at scale. Okay, so we build them, orchestrate them, operate them reliably with AgentOps. But how do we know what they're actually doing? How well they're performing? Why they made a weird decision, especially with hundreds of them interacting?
That is where observability of AI agents becomes absolutely crucial. You need deep visibility into these systems.
Observability, like monitoring.
It includes monitoring, but it's broader. It's about being able to ask questions about your system's state and behavior based on the data it emits. The white paper applies the 3 pillars of observability: logs, metrics, traces, but tailored for agents.
Okay, let's break that down. Logs first. How are agent logs different?
You still need the usual error warning logs, but you also need AI-specific stuff, critically.
Right.
Log the prompts going into LLMs and the full responses coming out.
The actual conversations.
Yes, though you need to be very careful with sensitive data and privacy here. Anonymization or filtering might be needed. Also, log key agent decisions. Agent decided to call tool X with parameters Y. This helps trace the reasoning. These decision logs plus prompt response logs act as explainability logs.
Seeing the inputs, outputs, and choices. But log volume could be huge.
It can be massive. You need strategies for sampling, aggregation, and efficient storage analysis.
Okay, logs give detailed event history. What about metrics? What numbers should we track?
Key metrics include throughput, tasks per minute, latency, how long tasks take, basic performance,
Standard stuff.
error rates by type if possible, task success failure rate. This is crucial. Does it actually achieve the business goal?
Right, the effectiveness.
For LLMs, token usage cost.
Right.
Maybe quality proxies like hallucination rate estimates or user feedback scores, standard resource metrics, CPU, memory, GPU,
Yeah.
and using queues, queue lengths.
A mix of technical cost and quality metrics. Got it. What's the third pillar?
Traces.
Distributed traces. These are incredibly powerful for multi-agent systems. They let you follow a single request as it bounces between different agents and services.
Wow.
You assign a unique trace ID when a request starts. Every time it moves to another agent or service, that ID travels with it. Each step gets a span ID.
So you can reconstruct the entire journey. Exactly. You get a timeline view. Requested agent A took 50 meters. Agent A called agent B, took 150 meters. Agent B called an external API, took 300 meters. You see the whole flow, the timings, the dependencies.
Wow. That sounds invaluable for debugging slowdowns or weird logic flows.
Totally. You can instantly see where the time went or where the process broke down. Correlates logs across services too. Essential for complex interactions.
Okay, logs, metrics, traces. How do you actually implement this telemetry capture?
Use standard libraries like the OpenTelemetry SDKs within your agent code. It's vendor neutral, supports traces and metrics. For logs, use a structured format like JSON. Include trace IDs and agent info.
And collect it all centrally?
Yes. Send logs, metrics, traces to a centralized observability platform. Tools like the ELK stack, Datadog, Honeycomb, Splunk, Prometheus Grafana, Jaeger. Lots of options. Cloud providers have native ones too.
Standardized capture, centralized collection. What are the most important metrics to watch, according to the paper?
Throughput and latency tell you about performance.
Yeah.
Error rates alert you to problems. Task success rate tells you if it's working. Token usage tracks cost.
Yeah.
Quality metrics, maybe from user feedback or AI checks, track, well, quality. And system-wide metrics like active agents or queue lengths show overall health.
A dashboard with all that would be powerful.
Absolutely. You need dashboards high level for execs, detailed for ops devs. Mix technical metrics with business KPIs. Set up alerts on critical failures, high errors, low success rate, and maybe warnings for anomalies or quality dips.
Proactive alerting, not just dashboards. The paper also mentions specific AI logging again.
Yeah, digging into explainability, semantic logging, log the why. Agent chose strategy A because of condition B. Maybe log the LLM's chain of thought if available. Keep detailed interaction logs for multi-agent conversations.
But handle the sensitive data carefully.
Always. Anonymize, control access. But these detailed logs are gold for debugging and improving the AI's reasoning.
Makes sense. And tools mentioned were Datadog, OpenTelemetry, Honeycomb, Prometheus Grafana, ELK.
Yep, those are some of the major players in the observability space that can handle this kind of data.
So observability isn't optional. It's how you understand and manage these complex, sometimes unpredictable systems.
Exactly. It turns the black box into a glass box, essential for trust, troubleshooting, and continuous improvement.
Okay, we've covered a lot of ground on the tech side, building, running, observing. But what about the money? Running potentially thousands of agents, hitting expensive LLM APIs, using cloud resources. That sounds costly.
You are absolutely right. Scale brings cost. And that's where the final piece of the puzzle comes in. FinOps for Agentic AI.
FinOps. Like DevOps, but for finance.
Pretty much. It's about bringing financial accountability and optimization practices to your cloud and AI spending. Understanding costs, managing them proactively, and linking them to business value. Crucial as AI scales up.
Okay, so how do you apply FinOps to these agent systems? What are the key practices?
Foundationally, cost attribution and tagging. You have to know which agent, which team, which project is using which resources.
How do you track that?
Tag everything relentlessly. Cloud instances, databases, API calls, .tag with agent name, team, project ID. Use cloud provider tagging features. Maybe use separate API keys per agent team for external services like LLMs. Keep an internal map of these tags. Use cost management tools to filter by tags.
Meticulous labeling to see who spends what. Got it. What's next?
Per call metering and cost awareness. Try to understand the cost of each agent interaction. Estimate compute cost per call. Calculate LLM API costs based on tokens used, factor in storage, network.
Granular cost visibility.
Yes, when developers see that a particular agent design costs 0.05 cents per call versus an alternative at 0.01 others, it drives cost-conscious design choices. Choosing the right model, optimizing prompts.
Makes cost a design consideration smart. How do you justify the spend?
Track ROI metrics. Quantify the value. How much human time is saved? How much faster is revenue generated? Are errors reduced? Can we operate at a scale impossible before?
Measure the benefits.
And crucially, pair the cost data with the value data on dashboards. Show leadership. This agent system costs X, but it delivers Y value. That's the conversation you need to have.
Connecting cost to value. Essential. What about managing the budget?
Budgeting, forecasting, and optimization. Work with finance to set realistic AI budgets. Forecast future spend based on usage trends and new deployments. Use cloud cost tools to model scenarios. Create FinOps dashboards showing spend versus budget, cost trends, cost per business transaction. Identify expensive agents or processes.
Proactive financial planning and ongoing monitoring. Are there specific ways to optimize AI costs?
Yes, model tiering and cost-aware strategies. Don't use the most expensive, powerful LLM for every single task. Use smaller, cheaper models for simpler things.
Right-size the model to the job.
Implement caching for repeated requests. Batch requests to LLMs to reduce overhead. Schedule expensive batch jobs for off-peak hours if possible. Maybe even design for graceful degradation if budget is tight. Temporarily disable a non-critical expensive feature.
Smart cost-saving tactics. What about preventing runaway costs?
Automated cost governance. Set up alerts for budget thresholds or spending anomalies. Use cost limits or quotas provided by cloud platforms or API vendors, like OpenAI API limits. Have a cost review process for new agents before deployment. Automatically clean up untagged or old experimental resources.
Guardrails and automation to control spending. The paper listed some tools here, too.
Yeah, specialized tools like Cloud Zero, FinOps, plus the native cloud tools, AWS Cost Explorer, Azure Cost Management, Google Cloud Cost Management, and vendor dashboards like OpenAI's usage tracking.
So FinOps isn't just about tracking. It's about active management and optimization.
Absolutely. It ensures financial sustainability. It also forces consideration of things like build versus buy for models as you scale.
Yeah.
Maybe hosting your own becomes cheaper eventually. And exploring fine-tuning smaller models on your data can sometimes give you good performance at much lower cost.
Okay. Wow. This has been, a real deep dive. We've gone from the basics of agentic AI all the way through orchestration, reliability, operations, observability, and now FinOps.
It really highlights that scaling agentic AI isn't just about writing smart code for individual agents. It's about building this entire surrounding platform.
Right. The orchestration layer, the communication protocols, the AgentOps practices, the observability tooling, the FinOps discipline. It's the whole ecosystem.
Exactly. That's what enables you to go from cool demos to enterprise-grade, reliable, manageable, and value-generating deployments. You need that robust infrastructure and those disciplined practices.
And it really underscores the need for collaboration, doesn't it? Engineering, data science, DevOps SREs, security, finance, they all have to work together on this.
Couldn't agree more. It's inherently cross-functional. Building this platform and making it work requires breaking down those traditional silos.
So by investing in these platform capabilities, orchestration, operations, observability, finance, and fostering that collaboration,
Organizations can really start to unlock the true potential of agentic AI, drive real innovation, boost productivity, gain competitive advantages, but do it in a way that's controlled, visible, and efficient.
Okay. So for you, the listener, as you think about all this, for your own company or projects, maybe consider which of these areas feels like the most immediate bottleneck or the biggest opportunity right now.
Yeah, is it the basic orchestration, getting agents to talk reliably? Is it the operational side deployment, testing? Is it visibility, just understanding what's going on? Or is it the cost getting out of hand?
Where would focusing your attention yield the biggest return as you scale up your AI efforts? Because, as we've seen, the intelligence of the agents themselves is only part of the story.
It's the whole system, the whole platform you build around them that really determines success at scale.